All right, we are ready for lesson 9.5, the quadratic formula. Some of the equations that we had back in chapter 8, or the trinomials that we wanted to factor, we couldn't find factors for them, or whole number factors for them at least, and so we called those prime, or we said they wouldn't factor. But there is a way. There is a way to factor any equation, and quadratic formula will work for any trinomial that you need to factor, equation or problem or whatever. Okay, so this is kind of the, it's the method that will work for any of them, but it's not always the simplest method because some of them factor real easy using the box method, or the numbers aren't that hard to work with, so we can factor them kind of in our heads or whatever. But in this case, the quadratic formula will always work for all of them. So this is the quadratic formula. And it's said like this: x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. It's just a formula. All we've got to do is plug in the b's, the a's, and the c's, and then solve it. And so you guys know how to do every one of these steps. You know how to make a number negative. You know how to do addition and subtraction. You know how to do square roots. You know how to square numbers. You know how to multiply. You know how to work with fractions. All the things that are involved in this formula, you know how to do. It looks kind of scary because there's so many letters in it, but it's really not that big of a deal. We also, the thing that's important is to remember what a trinomial equation looks like, or quadratic equation looks like this, because you've got that leading coefficient, which will always be the a value. You've got your second coefficient, which is the b, and then you have a constant, which is c. So you have to have it written in standard form. You have to have these numbers in the right order so that the a's, the b's, and the c's are all the right numbers, right? Okay, so we're going to start off, and this equation is pretty simple. It's going to come out as whole numbers. We actually could factor this one pretty quickly using the box method if we wanted to, but I wanted to choose a simple equation first that will factor easily, just to show you how the formula works. Later on, we're going to get into some that come out with some weird numbers, but it's okay. Numbers can be weird sometimes. So all we have to do is plug things into the formula. X equals negative, and what is b? Negative 12. So it's a negative 12. See how that works? Plus or minus the square root of b squared, so that's negative 12 squared, minus 4 times, what's a?
X squared.
A is not x, a is the coefficient. A is 1 times c, which is 20. And all of that goes over 2 times a, which is 1. Now all we have to do is simplify. Okay, I know that's all we have to do, but that really is all we have to do. Just simplify each step along the way. So a negative 12 is a positive 12. Plus or minus the square root. What's negative 12 squared? Positive 144. Minus, what's 4 times 1 is 4, times 20 is 80. So minus 80, and it's all over 2. All right, so now simplify another step. X equals 12 plus or minus the square root. What's 144 minus 80?
64.
Minus the square root of 64, or plus or minus the square root of 64, all over 2. Now, once we're down to this step, we've only done things, we've done stuff once, right? And so here, well, I guess we can actually go one more step. X equals 12 plus or minus what? 8 over 2. Now, I've just got 2 more steps, and I'm solved. I'm going to do one step as x, block this off so that it doesn't run together. X equals 12 plus 8 which is 20, right? Or x equals 12 minus 8, which is 4. And it's, oh, wait a minute. It's over 2. I forgot the over 2 part. I knew that wasn't coming out right. So 20 over 2, so x equals 10 or x equals 2. Now this one, I'm telling you, this one would have factored real easy using the box method and we'd have been done already, right? So quadratic equation is not the one that you always want to use because it's sometimes long drawn out. Try the box method first. If the box method works, great, you're done. If it doesn't work, if you can't factor it using the box method, then you have this as the fallback, and all you have to do is plug things into the equation, and it will factor things that we can't factor otherwise. All right, we're just going to go through like what, 4 more of these. I'm just going to let you see how the equation works, how it can come out to some weird numbers, and it's okay. And then you're going to have an assignment where you use the quadratic formula. All right, make my pen a little smaller so I can write smaller. And I'm going to change to blue because that makes me happy. All right, so x equals negative b, which is 9 plus or minus the square root of 9 squared minus 4 times 2 times negative 18. Don't forget symbols. All over 2 times 2. So x equals negative 9 plus or minus square root of 81. 4 times 2 is 8. 8 times 18 is 144. So and it's going to be a minus times a minus is a plus. So it's going to be plus 144. That make sense? And then it's all over 4. X equals negative 9 plus or minus the square root of 225? Is that right? 225? Okay. All over 4. Square root of 225 is what? 15. So x equals negative 9 plus or minus 15 all over 4. So x equals negative 9 plus 15 over 4. Negative 9 plus 15 would be 6, right? 6 over 4, which is 3 over 2. So 3 over 2. So yeah, or I'll just leave it like this. If you want to write it as 1.5, that's fine. Or we can do x equals negative 9 minus 15 over 4. So negative 9 minus 15 is negative 24. Over 4 is negative 6. So x equals negative 6 or 3/2. Now here's one that we could not have factored with the box method because we never used fractions with the box method, did we? We always used whole numbers. That's the only way that method really works for us. And so here we came out with one that we couldn't factor otherwise. We came up with an answer for one that we couldn't factor otherwise. Okay? And that's what the quadratic formula does for us. That's the reason it was invented, or discovered, I suppose. Not invented, is so that we could factor things that won't factor otherwise. All right. Yet another example. Negative b would be negative 5 plus or minus square root of what? 5 squared minus 4 times not 5. 3 times negative 12. All over 2 times 3. All right, so x equals negative 5. Oops, forgot a step there. Plus or minus 25 plus, oh, I forgot this should be a negative 12 here, right? So it should be 12 times 12 is 144, so plus 144 all over 6. So it's negative 5 plus or minus square root of 169.
Yep.
All over 6. So x equals negative 5 plus or minus 13 over 6. X equals negative 5 plus 13 over 6. Negative 5 plus 13 would be 6, right? So 6 over 6 is 1. Or x equals negative 5 minus 13, which...
Wait, no, it's 8.
5 plus 13 is 8.
Yeah.
Oh, okay, thank you. I wanted it to work out to 6 in my head. I'm sorry. So this, don't make calculation errors. Sorry about that. So it would be 8/6, which is 4/3. Negative 5 minus 13 over 6. Negative 18 over 6 is negative 3. So x equals negative 3 or 4/3. Answers can get even weirder. I know, right? And the good thing about this too, I think one of the good things about the formula is it doesn't matter if you have big numbers because you're going to do all this stuff with calculators anyway, right? When you're doing the box method, then you have to worry about if the numbers get really big, then it gets harder to factor. So here, big numbers are not a problem. Negative 9 plus or minus the square root of 9 squared minus 4 times 10 times minus 18 times negative 18. That's all over 2 times 10. 2a. X equals, oh, why did I do that? Okay, negative 9 plus or minus square root of 81 plus 180, 70, 720, 720, 81 plus 720, all over 20. So it's negative 9 plus or minus the square root of 801. Is that right? 801. All over 20. So x equals negative 9 plus or minus, what is the square root of 801? 28.30. 28.30. 28.30. So 28.3. All over 20. you will find, I think you will find some teachers or situations where they'll actually kind of want you to stop here. Or maybe we went through simplifying radicals yesterday. If this simplified in some way, simplifying that would be okay, but they'll want you to stop here because it preserves the answer in a way that you could kind of rebuild it. Once you do this to a decimal, if this is the only answer I can see, then it gets hard to understand how you got there from that point. But for now, I'm looking for the two factors, so I want you to go on with this and answer it. But just, sometimes you may want to stop here too. All right. I know anytime you guys can just stop a problem midway through, you love that. X equals -9 plus 28.3 over 20. So you just put that into your calculator. It's going to be a weird number, but you round it to the nearest hundredth and you're good. 1.86 can't be that high. 1.0.
1.87.
1.8?
I got it.
No, if it's the
Can't
plus
be.
one, it's 0.96.
Yeah, it's got to be
That's what I got for the plus.
less than, because this is going to be like 19.7 or something, isn't it? 19.7 over 20. So it's point what?
0.96.
0.96.
965.
965, so it's 0.97. All right, 0.97. And then you have x equals -9 minus 28.3 over 20. And this one is 1.8, 1.87. So x is 1.87 or 0.97. That is a weird solution, okay? All right. Last one that we're going to do together. X equals -4 plus or minus the square root of -4 squared minus 4 times 4 times -11. All over 2 times 4. So x equals 4 plus or minus the square root of 16 plus 176. Positive one is plus 176. All over 8. So x equals 4 plus or minus square root of 192 over 8. Point what? 13 point. Give me two digits. 86. Okay, 86. All over 8. So x equals 4 plus 13.86 divided by 8. So 17.86 divided by 8.
2.2.
2.23, and that's pretty good. I think the book said 2.2, about 2.2. And x equals 4 minus 13.86 over 8. -1 point what? 23. So x equals -1.23 or 2.23.
Fish?
One moment, please.